Alright, this is going through the project portion. Okay, this is a proof about the areas, about the Pythagorean theorem that was discovered by one of our former presidents of the United States. Okay, and so here's what he did. In order to prove that a squared plus b squared equals c squared. First step was to write the area of the trapezoid in terms of a and b. So notice we do have a trapezoid figure here. Let me go ahead and outline it. Also recall that the formula for the area of a trapezoid is the height times the two bases added together, all divided by 2. Okay, so in this trapezoid, here's our bases. One base is A, the other base is B. The height is this distance here. Notice in that it has an A and the rest is B, so all together it would be A plus B. Let's put those into our formula. So our height is A plus B. Our bases are A and B, so base 1 plus base 2 is A plus B also, all divided by 2. Okay, remember when you have something times itself, another way to write that is as A plus B times itself is to write A plus B squared. We have 1/2 of that. Okay, so there's the first part. Okay, so that got started. Then okay, so the next step after you've written the area of the trapezoid in terms of A and B is to write the area of the, sorry, a typo there, the area of the 3 triangles in terms of A and B. So let's look at our first triangle over here on the left. Our base is A, our height is B, and the area of a triangle is 1/2 base times height. So yet area is 1/2 A times B. Let's take a look over on this side. Again, we have a triangle, A times B, that would be my base and my height. So I have another one that's 1/2 A times B. Finally, the big white figure here. Okay, well, look at its base and height. Its base is C, and its height is C. But they wanted its area in terms of A and B. Okay, height and base C, our final area is 1/2 C times C, okay, which we write as C squared. Okay, so here are my 3 triangles. If I add them together, I'd have 1/2 AB plus 1/2 AB plus 1/2 C squared. Alright, so do you have those down as we go to our last page? So the area of the trapezoid, if we used a trapezoid, was 1/2 times A plus B squared. And if we looked at it in each of the 3 triangles, we had 1/2 AB, another 1/2 AB, and a 1/2 C squared. It says you can now set the area of the trapezoid equal to the sum of the area of the 3 triangles. Okay, so I didn't have that written down, so I better go back and take a look. To the area of the trapezoid was 1/2 times A plus B squared. I'm going to set that equal to the 3 triangles added together, so 1/2 AB, or 1/2 AB, and something, what was the last one? 1/2 C squared. Alright, so we want to show that these 2 things are equal. So let's simplify a little bit. I'm going to multiply by 2, and on this side and multiply by 2 everywhere else. Keep it balanced. What I do, I end up with a plus b squared equals ab plus ab plus c squared. Now what does a plus b squared mean? Remember, that means a plus b times a plus b. Let's find out what that is equivalent to so that then we can solve this problem. We have to distribute to get rid of parentheses. This is actually foiling, is what it's called, to foil. First outside, inside, last. So we have to take a times a gives us a squared, and then a times the second part, b, so ab plus b times a is ab, and b times b is b squared. That is all equal to ab plus ab, or 2ab plus c squared. Over here, notice we also have a 2ab. We have an a squared plus 2ab's plus b squared equals 2ab plus c squared. Alright, so where do we go from there? Well, notice we have ab's on both sides. So I'm going to subtract 2ab. If I subtract 2ab from the other side, notice they cancel. So now I have a squared plus b squared equals c squared. And we have derived the formula for the Pythagorean theorem.